Hi guys, Mr. Hayes here. I'm just going to do a very quick video on how to answer the questions for this half cell. And so we're looking at the molten carbonate fuel cell. So this is the one that we did in class. I'm just going to clarify a few things about what we should be looking for. Now, this is the carbonate fuel cell, being that it uses carbonate as an electrolyte. There are a few different electrolytes that we could be seeing. H+, which is in the acidic fuel cells, and it will usually be called some kind of acidic fuel cell. OH-, it's not letting me do that. OH-, which is the alkaline. Sorry, I was about to write hydroxide, which it is, but I'll write alkaline fuel cell. The other ones are the CO3 2-, this one, which is the carbonate. And then also there is O2-. Now there are some other variations of these fuel cells, which is why we have 6 in the textbook. And just to be very clear, they are in the textbook in chapter 5, and they are also in your booklet, our class notes. So make sure that you're looking along on these notes if you aren't clear about the difference between these, because we've been working with them for long enough now. They should be pretty familiar. And so if you need to work out half equations, they're going to start popping up more and more. There aren't an infinite number of fuel cells you'll see. There are 6 different ones. So try and get familiar with each of these. The one that we are looking at in this scenario is the carbonate. So I'll get rid of those two and I will get rid of that one. So to answer the question, what are the 2 reactants of the fuel cell above? Hydrogen, oxygen, not carbon dioxide. And when we look at the overall equation, it becomes pretty clear why. However, these are our 2 reactants. So let's write them here. Let me clear this. What's the product in the next question? Our product is, the only thing that's coming out of this fuel cell is water and heat. And of course, heat is not a chemical, so we just write water. Then from here, write the half equations happening at the anode and cathode. So to be able to do this, I need to identify which one is which. So firstly, I'm going to write that over here is the anode, and I know that it's not there, it's just on this side. I know that it's actually there, but I'm just going to write anode for clarity, which must mean that the other one is cathode. Now, how do I know that they are the anode and the cathode? Because up here, I can see the anode is losing electrons, because remember, oxidation is the loss of electrons. It will be pushing and losing those electrons to the other half cell. And remember our little mnemonic device where it's anox, red cat. So anode is oxidation and reduction happens at the cathode. Anox, red cat. And then of course we've got electrons coming into the cathode there because it's gaining electrons. Remember, oil rig as well is important to remember. All right, so for this left one, the anode, or the oxidation half equation, we're going to have a quick look at the reactants and the products. Reactant here, reactant here. The top left one, the hydrogen, is quite easy because it's coming in through an inlet tube or some kind of opening, whereas the carbonate in the center is the electrolyte. It's kind of hard, but you can see them pointing towards each other, which is our biggest indication. It's saying that they react here at this electrode to produce electrons. And so I can start writing my skeleton equation here. H2 plus CO3 2-. And I'll leave that like that there for now. I come back up. What else is important here? I have a product, carbon dioxide, and another product, water. So I'm going to write them into my equation down here. So I have CO2 plus H2O. And if I look back again, one last check, I can see there's no other chemical that could possibly be involved here. I can see there's kind of water coming out here, but that's already indicated right there. Heat, which is not important. So that's it. All right, that's it. Let's go back down. Alrighty. Let's now try and balance this. Make sure it's a complete half equation because it's just a skeleton right now with what I've seen in the diagram. We're going to use our KOHES method. Just being careful that if I did need to balance for hydrogen, I would not be using H+. So H+ does not occur here. What I would then need to do is try and balance using my species that have hydrogen in there. But we haven't even seen if we need to do that yet, so let's check. I'm going to check to see if my key element, which is carbon, is balanced. So I can see here, I've got 1 carbon and 1 carbon. So it is balanced. Let's now move on to the oxygens. So oxygen, I have 3, and I have 2 and 1, that's 3. Awesome. Let's go to the hydrogens. So hydrogen, I can see there is 2 here and 2 here. So everything's balanced so far in terms of our atoms. The atom economy is satisfied. I can then go across to my electrons. Now, where would I add those? I can see that there's a -2 charge here. So I would then need to add 2 electrons to the right side to make sure that both sides have a charge of -2. Last thing, states, gas, liquid because it's molten carbonate, gas, gas. So that's all there. I'm going to move on now to my cathode. So let's have a look here. I'll make it red to make it clear. We have oxygen, carbon dioxide, which are our 2 reactants, which I'll write down here. O2 plus CO2. There's no other chemical coming in to that side, so they must be the only 2 reactants for that half equation. But then also it's producing carbonate, and so I can see that here, and it makes it clear about why carbonate is not really a product or a reactant of the overall equation. The overall fuel cell, it's just participating in the middle. It's because it's produced and used as a reactant in each of those half equations. So I'm going to write CO3 2 minus. That's our product of this one. I'm going to leave it there for that, which is all of our species in there. So I'm going to start to balance using my KOHES method, being very careful that I cannot balance with the hydrogen again. Remember, I have to balance using what I've got. So let's go here. I have 1 carbon, 1 carbon. So that's balanced. Key elements are balanced. I have 2 oxygens and 2 oxygens. That's 4 in total, but I have 3 over here. So I've got a problem. I need to balance my oxygens. Normally I would balance them using water. Now, I'm not going to balance them using water because if I use water, I'm going to end up with H plus ions. And I do not have H plus ions anywhere here, so I'm not going to balance using water. I'm going to go back down, and I'm going to actually balance using the standard chemical equation balancing method we use in high school. And I mean, high school is in like year 10 or year 11. We have learned these in previous years. We are going to put coefficients in front of our key elements first and balance them first before we do anything else. We don't need to. So now we're going to go to the next one, which is oxygen. I'm going to balance my oxygen. The first thing I would need to do is put a 2 here. Why? Because if I put a 2 here or here, it's going to increase the amount of oxygens on my left side, which is already at 4, whereas the right side's on 3. And so if I increase my left side above 4, it's not helping me get any closer to balancing that equation. So I'm going to make sure that I increase the coefficient on the right side somewhere, and it makes sense that it's the only product we have, which is the carbonate. So I put a 2 there, and I'm going to change my tally. I now have 2 and 6. This is starting to look pretty promising. I could now put a number here or here. I'll let you think for a second about what you probably want to do, but I would make sure that I'm considering both chemicals here. Why would I want to put a number here and increase the number of oxygens when I need to balance both my carbons now? I can see that I've got 2 on the right, 1 on the left. So I'm actually going to put a number here where you can see that blue line. I'm going to put a 2 there, and that's going to increase both of these up to 2 and 4, okay? And so that's increased now. I'm going to leave that like that, and I'm going to check. So I have 1, 2, 3, 4, 5, 6 oxygens, and I've got 6 on the right. Carbons, I have 1, 2, and then on the right, I have 1, 2. So this is completely done. My atoms are balanced, so I can then go on and I can balance my electrons, my charge. What do I have? I have 2 times 2 negative charges, or 2 minus charges, which means I have a -4 charge on the right-hand side, which means I need to balance that on my left, which is neutral right now. I need to add 4 electrons to this side. I know it's a little bit messy, but that is a balanced equation for my cathode reaction. I'm going to put a few different states here: gas for oxygen, gas for carbon dioxide, liquid for molten carbonate, because it's melted. Remember that, okay? I'm very quickly going to do my overall equation, but essentially what I'm looking for is for the 2 electrons to be equal. And so what I would need to do is I need to times one of these equations by a certain number to make these electrons the same value. So the easiest thing to do here would be to times the top anode equation by 2. Everything by 2, all the coefficients will be doubled. So let me do this down here, okay? Let me go, so anode, and I'm going to put in brackets 2 times dot dot. So I've got 2H2 plus 2CO3 2 minus 2CO2 plus 2H2O, and then I've got 4E minus now, because remember I times that by 2. Then the cathode is exactly as it is. Okay, I wrote those out again because a question would normally have different parts. Let's imagine that's I, this is I. And so if I then go and try and multiply these out and put numbers here, technically that's not correct. I'm starting to say that for my anode reaction, this is the most simple version of it I can give you, when in fact that's not correct. So you will need to write it out again. If you need to use that for your calculations, I would recommend doing that if you have time, just to make sure that if these are parts of the question that are marked, you are not providing an incorrect answer just because you're using it for your calculations. Write it out again and use it here for your calculations of this question. Okay, so H2 in my anode reaction, I can't see it anywhere else, so I'm just going to keep it for now. I can see carbonate in my anode reaction is going to cancel out with carbonate here. There's 2 carbonates at the top, 2 carbonates at the bottom on the right, so I cancel. In the product line of the anode reaction, I have 2 carbon dioxides and I have 2 carbon dioxides in the reactant part of the cathode reaction. Last thing, water is by itself. There's no water anywhere else, so I don't cancel. The electrons do cancel. Okay, so then I'm going to write down everything that's still present. I have 2H2 plus O2 goes to 2H2O, because I'm making sure I'm writing this is important, and this. All the things that aren't crossed out, and obviously I don't double dip with my arrow. From here, I'm not done. I can quickly check just to make sure that the atoms are all counting up correctly. It's balanced. I can see I've got 4 hydrogens here, and I've got 2 oxygens. Here I've got 4 hydrogens and 2 oxygens. You don't need to write that down. Sometimes you can just do that in your head, and I'm making a mess of everything here, but don't worry too much about that. Let me fix that up. Then I'm going to put the states. Gas, gas, gas. Gas because this is a molten carbonate fuel cell. It's very hot. Liquid water would be vaporized very, very quickly. Now, one thing I am going to tell you in this video, advantages and disadvantages of fuel cells over galvanic cells, or whatever the question's asking you, it's important to know those. So they are in the textbook. They are outlined pretty clearly in a table in the fuel cell section. It's important to know what the advantages are of fuel cells over galvanic cells. And there's a few things. It's continuous energy production. It's things like fuel efficiency, being able to convert all of the chemical energy into electrical energy. And there are a few others, but make sure that you are all over those for the SAC as well. I'm going to leave it there, guys. If you have any questions, send me an email and I'll make sure to clarify that up for you. All the best, and I'll see you during the SAC.